This update was not supposed to happen today. NASA's orbital model for 3I/ATLS was considered stable until the newest data came in. Because according to the latest trajectory update, 3I/ATLS is no longer following the path predicted by gravity alone. And that's not speculation. That's not theory. That's written directly into the updated orbit. Here's why this matters. Interstellar objects don't just drift off course. They don't randomly change direction after leaving the sun. When they do, it means something physical has changed inside the object itself. And today, the math stopped lining up. NASA didn't announce it loudly. There was no press conference, but the numbers were quietly adjusted. And those numbers tell us one thing very clearly. 3I/ATLS is applying force where no force should exist. Let me explain what that actually means. Every object moving through space follows a predictable path. Gravity from the sun, gravity from the planets, nothing else. For weeks, 3I/ATLS followed that script perfectly. Its position matched predictions down to tiny margins. But in the latest update, scientists noticed something unsettling. The object was no longer where it should be. Not by a lot, not dramatically, but enough to matter. The deviation wasn't random. It wasn't noise. It leaned consistently in one direction. That's the key. When errors scatter randomly, it's measurement noise. When they lean the same way, it means real force is acting. To fix the mismatch, NASA had to adjust something called non-gravitational parameters. That term sounds boring, but it's important. It means forces that are not gravity. In simple terms, the model now assumes that 3I/ATLS is pushing itself sideways. That should immediately make you pause, because gravity doesn't do sideways pushes, and space doesn't have wind. So where is that force coming from? The usual answer would be outgassing. Comets heat up, ice turns to gas jets push the object like tiny thrusters. But here's the problem. 3I/ATLS is moving away from the sun. It should be cooling down. Its activity should be decreasing. Instead, the opposite happened. The sideways acceleration increased. That alone is abnormal, but the images made it worse. When astronomers compared the latest images with earlier ones, the inner coma looked different. The brightness was no longer centered. It had shifted. That tells us material is no longer venting evenly. One side of the object has become more active than the others. That means something inside cracked open, heated up, or reconfigured. And that's dangerous. Because when jets fire unevenly, they don't just move the object, they twist it. They apply torque. Torque spins objects faster. And comets are fragile. If the rotation speeds up too much, the nucleus can tear itself apart. We've seen this before. Comets act strange. They change brightness. They alter trajectory. Then suddenly, they fragment. And this is exactly how it starts. NASA's language stays cautious. They call it updated orbital solution. They don't say unstable, but the physics is clear. 3I/ATLS is no longer behaving like a passive interstellar rock. Something inside it is active. Something has changed recently, and the change is ongoing. That's why this update matters so much. This wasn't a one-time correction. It reflects behavior observed over multiple data points, which means the force is persistent. If it continues, the orbit will keep shifting, and that raises uncomfortable questions. Will the activity increase? Will new jets open? Will the spin rate rise? Or will the object break apart before we ever get clear answers? Right now, no one knows. But here's what makes this even more interesting. This is not the first interstellar object to defy expectations. Oumuamua showed unexplained acceleration without visible outgassing. Now 3I/ATLS is showing unexplained orbital changes driven by asymmetric forces. Different objects, different behaviors, same problem. Our models are incomplete. Interstellar space is not as simple as we thought, and objects entering our system may react in ways we don't fully understand. 3I/ATLS isn't dangerous to Earth, let's be clear about that, but scientifically, it's a warning sign. It tells us that when matter from another solar system enters ours, it doesn't always behave by our rules, and that's exactly why scientists are watching this so closely. Every new observation tightens the mystery. Either the activity fades and stabilizes, or the object continues to push itself off course. If that happens, the next update may not be quiet, because once an object starts breaking its own orbit, it's no longer just passing through. It's evolving, and evolution in space is never boring. This story isn't over, and the next data drop could change everything.